Good morning everyone. I hope everyone is doing well today. My name is Aishwarya Sindhu Ramachandran and I will be a science educator, and we are back with an amazing rapid recap session, and this is on the topic called motion and measurement of distances. So we will be covering a lot of concepts today, so please have a notebook and a pen along with you so you can note down the important points as we are going to discuss multiple things. And not only that, please comment your doubts in the comment box here. So I am here to resolve it for you, and let's dive into the session here. And these are the main contexts that we will be discussing today, starting from rest and motion, ancient units, standardization, types of error, types of motion, and finally speed. So these are the concepts that we will be learning today, and let's start off with the first part. It's all about rest and motion. To help me out, my friend Reena is also here. So Reena is going to have an amazing trip to Manali, but when you look at her position, let's list it out as number 1. So this is a very first position, but even with the passage of time, there is no change in her position, right? Yes, so time cannot be stopped by anyone. So time is just moving in the forward direction. Nobody can stop it, right? But what about a position? Is there any change in the position? No, there is no position change. So you have to understand that there is no position change with respect to time. That's very, very important. No position change. So from itself, it's very clear that if a body is said to be at rest, then the body should not have any kind of position change with respect to time. Very simple. And now we are moving towards the concept of motion. And this is also very, very simple. And this is her very first position. And this is her second position. So you can see that time cannot be stopped by anyone, right? Yes. So time is actually moving in the positive direction. But what about a position? Did it change? Yes, of course. The position has changed from 1 to 2. So there is a position change. So you need to be very, very clear about it, that if there is a position change with respect to time, then the body is said to be in motion. Okay, now we are moving towards the next one, and look at it. It's all about modes of transport, and you can see that ancient people used to move from one place to another just by walk, but by the invention of a wheel, lot of advancements happened. And today we will be learning about mainly 3 types of modes, and here they are: air, water, and land. So when you just talk about this air, water, and land modes of transport, you must have to talk about the examples too. So when you talk about the air mode of transport, we know that there are 2: airplanes and helicopters. What about water transport? Very easy. Ships and boats are the various examples. What about next one? It's all about land transport. Very simple. We know that we have a lot of buses, trains, and also a lot of cars, right? That's all about the modes of transport. And now we are moving towards the next one, and it's all about length and distance. It's a very, very simple and easy concept. So what is length? Length is nothing but a quantity that is basically used to measure the dimensions of an object. It can be expressed in centimeter or millimeter, and you can make use of a scale to measure the length of it, right? Yes. But when it comes to the distance, that's where we need to talk about a lot many things more. Here we are going to take an example of Earth and Sun. So for example, if there is a distance between Earth and the Sun, this can be represented as 1 AU. So what is 1 AU? It's nothing but 1 astronomical unit, which represents the distance between Earth and the Sun. Similarly, we can also take this as an example, that if a person is traveling from Delhi to Alleppey, there must be a distance mentioned in kilometers. So this is also a distance only. And now, what is it all about? Yes, it's all about the measurement here. And measurement is nothing but a technique that has been used to find out the properties of an object using the comparison with a standard quantity. That is a part you need to understand here. So it's a very, very simple concept, and you can find multiple instances in our day-to-day lives where we take measurements to measure your height, to measure the length of your pencil or a pen, and many instances that we are using this. So let's take an example here. So here you can see that I'm going to measure the length of the pencil. So I should start from 0, then this is the end point, so it ends at 10. So what is the length of this one? It's going to be 10 centimeter. So it's a very, very simple one. And similar to that, here you can see that Papa is actually taking height of Arun. So it's very simple that there is actually a scale here. So this scale is nothing but the standard quantity. You have to understand that whenever you want to make a measurement, there must be a reference. So this reference can also be called it as a standard quantity, because these are the quantities that we take as a reference to measure some unknown quantities. And I hope you are clear with the point. And now what we are going to learn is all about unit. So unit is nothing but a standard quantity. You have to understand the terms really well. This is nothing but a very important standard quantity. And this standard quantity is known to us. Very important. This is a known quantity. So using this known quantity, we are going to find out some unknown quantity. Let's take an example so that you will understand it really well. So here you can see that a bottle full of mango juice. So I know that this bottle contains 1 liter of mango juice. It has 1 liter and this has 1 liter. So total of 2 liters, right? So this is what I know from the picture, correct? But how did I find this? Because using the 1 liter as a standard quantity, I'm going to find out what could be the amount of mango juice present in this particular 2 bottles. Correct? So it's very simple. So I have used this known quantity to find out the unknown quantity here. Simple, right? And now we are diving into ancient methods of measurement. So we know that measurement has been happening for years and years now. But ancient times, people used various units and various quantities to measure things. And that's what we are going to learn now. And here is the first one, and this is nothing but feet. So if you want to measure feet, very simple. From the tip to the end, that's all about feet. And what about this one? Stretch your fingers, then you have to take the length from the thumb to the little finger. So this is called hand span. And now we are going to learn about yard. So for that you need to measure from the nose to your extended fingertip. This is his nose. I'm going to make a small point here. From here to this end point can be called it as yard. And what about the last one? This is nothing but cubit. So cubit can be measured from elbow to your fingertip. So this is the way that you need to measure cubit. And yet there is a problem with this kind of measurement. Why? Because this can change from one person to another. The measurements will be different from one person to another. So this is not a standard one at all, right? And that is the reason we call these measurements as non-standard measurements or non-standard units. And I hope you are clear. And now we are going towards standardization, because I told you that difference in measurements can cause errors and irregularities. We need to standardize the units to make sure that it's equal everywhere, wherever you go in the world. And that's what we are going to learn now. And if you want to talk about standardization, let's take an example of 1 meter. So 1 meter has 100 centimeter. Correct. So 1 meter has 100 centimeter. Wherever you go, if you go to US or Canada or New Zealand or India, it's same everywhere, right? And that is where the standardization is very much required, and wherever you go, it's going to be same and uniform throughout. And now we are moving on to the next one. So when you take measurements, there are 2 ways in which you can get errors. The first one is nothing but zero error, and the second one is nothing but parallax error. So that's what we are going to learn now. So the first one is zero error, second one is parallax error. So let me tell you about zero error first. So here you can see that zero error happens when there is a defect in the reference. So let me tell you how it is possible. So you want to measure the length of the pencil. It's very easy that you have to start from 0 and you need to mark the end point. So the end point is actually 5. So what is the length of the pencil? Very simple. 5 centimeter. That's the length of the pencil. But what about this one? You can see the scale is actually broken. So at this point, you have to understand that the 0 marking is not visible. I can only see from number 2. So this is number 2, this is number 3, this is number 4, 5, 6, 7 and 8. So now how I am going to measure the pencil? So this is my initial point. So 2 is my initial point. And what is the end point here? It's nothing but 7. You can see that here. Correct? So if I want to measure the length of the pencil, it's simple that you need to subtract the final reading and the initial reading. So here 7 minus 2, that is equal to 5 centimeter. This is the correct way of taking the measurement. But if you are not doing in such a way, then you will get the zero error. And now we are going to learn about parallax error, and this error usually happens when your line of sight is not straight enough. So here you have to say that I'm going to take the measurement of the pencil again, but this one is actually correct. If you want to take the measurement of an object, the line of sight should be straight. Got it? This is the way that you need to take the measurement. I should not do like this or I should not go like this. You should be very clear that the line of sight should be straight enough to get a right reading. So this is right. And what about this one? This is wrong. This is also wrong. So these are the two positions where you get the parallax error, because there is a possibility that you will be seeing the reading like this. So now we are moving towards the very important point. It's all about measuring a curved line. It's very, very important. And this is applicable to all type of irregular bodies. For that, I'm going to take a irregular shaped body, and this irregular shaped body has to be wrapped with a string. So I need to know the length of the string that I have to use to wrap this one. So for that, I'm going to take a small red thread like this, and this red thread has to be wrapped. And if I want to know the length of it, I need to untie it and need to compare with the scale here. Got it? So I untied it, and now I need to compare with the reference or the scale or the standard quantity that has been shown here, so that I will get the length of it and I can definitely find the reading there. And this is how you need to measure a curved line. And now we are moving towards the next one, and it's all about types of motion. Very simple. So look at it here. You can see that the car is moving on a straight line. So if the car moves on a very straight line, it has a very specific name. This is called rectilinear motion. Rectilinear motion. And what about the second one? And here you can see that the car is actually moving around a circular path. So from the name itself, it is very evident that it's nothing but a circular motion. So please write it down. This is nothing but a circular motion. And what about the third one? And here you can see that the motion gets repeated after regular intervals. Easy to find out, right? Periodic motion. And that's all about the motion here. And now what we are going to learn is all about speed. And this is the very last concept of the chapter. So if you want to find out speed, very simple, you need to know the distance and the time, and divide each other, you will get the speed. Then if you want to know about the SI unit, it's very simple. It's nothing but meter per second. So please note it down. The SI unit of speed is nothing but meter per second. So that's all about it, and here we have learned multiple things, so please make sure that you're revising it every day. And we discussed about rest and motion, ancient units, standardization, types of error, types of motion, and finally speed. And that's all about it, and I hope everyone liked it, and please feel free to ask your doubts in the comment box. And that's all about today's class. We'll see you next day with an amazing session similar to this. Till then, have a nice day and goodbye everyone. Thank you so much.